I'd like to start with a couple of thoughts about some things that I heard earlier today. The conference was opened with some comments by Jonathan Wilkinson, and he was saying that one of the prime problems or challenges that we have is to take waste and turn it into things of value. What I'm here to talk about is actually the opposite, which is to say, I think it's very important that we take things that we value and start to understand them as waste. Buildings and architecture being a prime example of that. We think of buildings as being permanent. We think of buildings as being static, and that's by design. So a lot of this has to do with challenging those assumptions, and it has a lot to do with being able to look at buildings in a different kind of way as looking at the kind of systems, material systems, and infrastructural systems that make them the way that they are and start to impact the way that they are once their operational lifespans have ended. I'd also like to comment on something that sort of came out of Neri's talk, which was a matter of focusing on nature and then being challenged in terms of how do we apply that at scale. I also think that we can look at this in reverse and maybe meet each other halfway, which is to say, let's start looking at scale and look at things like infrastructure and actually understand them as natural kinds of systems. We live in the Anthropocene now. This is to say that human actions are the things that are dominating the way that our world is transforming. So why not consider things like infrastructure, like nature? At the end of the day, I'm an architectural designer. I'm a prof at an architecture program. I have 20 years of architectural experience. So my training is in thinking through problems by thinking through buildings and thinking through the systems that make them. So what we're going to be looking at is a series of projects that have taken place over the past 3 years or so through the Laboratory for Integrative Design. I'm one of 4 co-founders and directors of the laboratory, and what I really tried to do was start by looking at, in a sense, just quantifying demolition waste. That's it. Cities have a very limited view or limited capacity to track and quantify demolition waste. So what we do, or what we did, was start to pick through the very scarce information that exists out there on this and start to speculate on the impacts and the consequences and the territories that we might be able to look at further. It also revealed something in terms of how we start to consider our built environment. You see the image on the bottom right, and what you see is houses next to a landfill. Within the next 50 years, all of those houses will be in that landfill. Houses, no matter what their building performance improvements are today, actually are built pretty similarly to the way they were built 100 years ago, which is to say that they're probably going to be demolished the same way that they were 100 years ago or today. So we started picking through some of that information. We looked at demolition permits, the only information available to us, and we were able to interpolate, using GIS software, the intensity of this happening in Calgary. We started to zoom in on some of those most intense areas and map the level of redevelopment and infill development that was taking place there. And it led to an Urban Alliance project, which is a partnership between the university and the city, where we found a way to identify 20 houses which were about to be demolished. So this was an ongoing process. We would jump into the house, we would photograph it, we would do as-builts, we would build parametric models, we'd do material takeoffs, and we would also document the process of demolition, track the trash through the trucks going to the landfills or the transfer stations, and we were able to actually start to get real quantities coming out of these things. But it raised questions. It raised questions about why are buildings being demolished. It's possible to deconstruct buildings, but they don't want to be deconstructed. Buildings are designed to be monolithic. They're glued together. They're designed to stay there forever. And when it comes time to make them leave their site, it's a lot more simple and cost-effective to just demolish them and throw them away than to start to get into the nitty-grit. But that's a problem for design to tackle more than anything. If buildings are designed the same way that they always have been, they're going to be demolished the same way they always have been. So how do we make buildings do this? Well, the answer starts to be something that intersects between computation, logistics, design. Stop gluing things together, stop making buildings out of so many little parts, stop constructing buildings altogether. You start to look at prefabricated designs, and prefabricated housing is certainly something that's taking off. What you see is that buildings are not constructed anymore. They are fabricated in factories and assembled on site. That has massive, massive implications for the way that architecture can transform and be designed and be constructed and built. Prefabricated buildings allow for new technologies to be uptaken much, much more quickly. It also means that we can think about new levels of precision and digital manufacturing to produce new form. These are two projects that have taken place over the past 2 years. The image on the right is super recently completed. It's a sukkah for a Jewish congregation in Calgary. And we designed it so that it would be able to be assembled by really anybody in the congregation. Very simple bolted plate connections, somewhat complex form, but because we simplified the connection, it makes it very easy to both assemble and disassemble. And it's also reusable. It's reorientable. It has a number of ways it can be applied. The image on the left was also a very rapid project. We had about a month to design and then deliver this thing, but it was a project that was constructed at the university. We then put it into 4 chunks on a flatbed, took it downtown, and were able to assemble in a matter of hours. The sukkah, for example, takes 20 minutes to construct or to assemble on site and 20 minutes to disassemble on site. And all the pieces fit into a single U-Haul. So the Laboratory for Integrative Design is the outfit I'm affiliated with, making stuff and taking names. That's our MO.